Hey there, everybody. Welcome back. I am back in my shop from Retro World Expo 2025. I had an absolutely amazing time, and thankfully, I was able to have some help. One of those helpers was my friend and attorney, the 8-Bit Esquire. Yes, he came out of hiding to help me film this presentation, so we need to send him a special thank you in the comments. Today, you're going to get to see again that presentation I did. My CRT Masterclass for 2025. Now, these experiences are basically one-shot deals. I try to make them very unique, so this one will really never be done again. So this is the only opportunity you'll get to see it if you were not there at the show. And if you did come to the show, thank you very much for coming to Retro World. We always have an amazing experience at Retro World, and I have an even bigger plan for next year's Retro World. And just to give you a little bit of a teaser for it, I'm thinking about a hands-on experience on a CRT course, and that's just all I want to taste. I just want to leave you a little taste there. So if you ever think that, man, maybe I really want to see an experience like that or be involved in an experience or a class, then you'll want to start planning for Retro World 2026. Anyway, that's a lot of stuff. I'll leave you some more information at the very end of this video on how you can get in touch with me and learn more about CRTs if that's what you want to do. The last thing I want to say is this presentation goes into some pretty interesting myths on CRTs and that kind of technology. Everything here that I explain is from my personal experience and from my personal knowledge, and everything I've learned along the way of doing this and working on CRTs for the last decade. And hey, feel free to question me on anything that I say here. I'm not the one who always says I'm 100% right. Actually, I'm probably wrong. So just remember, question everything in life, okay? And with all that out of the way, thank you very much again for joining me today and watching this presentation. I hope you enjoy the Retro World Expo CRT Masterclass 2025.
Just 1, 2. We're good. 3, 4.
How's everybody doing today? I'm really glad that you guys all took time out of this amazing weekend to spend it with me here. Looking at CRTs today. I see a lot of you guys that were at my show last year here at Retro World, so I'm not going to make it redundant for you. I'm trying to make things a little different every time I do this presentation. And I don't know, I know a lot of you guys who were here last year may have saw, I came in a little bit late and was flustered, and I must have had 100 useless items that I didn't even get to show off. So I tried to tone it down this year and only brought like 15 useless things that I probably will not get to show off, but I'll do my best to not be Retro's version of Carrot Top. So today I have a couple CRTs here. If you were here last year or any of my conferences ever, for some reason you will recognize old Betty here. This is Betty, the beat up PVM. The good thing about Betty is she's pretty transparent. You get to see everything with her. So the good thing is her flaws let you see behind the curtain of a professional video monitor. A monitor like this is made by Sony, Trinitron, and then I have, this is a high-end piece of equipment. And then you go all the way to the exact opposite end of that spectrum, and you have my little friend Mag here. Mag is a simple 13-inch run-of-the-mill RF only, old school. It's actually called a hot TV and or a hot chassis. So while it does have its beautiful allure of static here, it cannot do nearly as much as something like this professional video monitor can. Now, I know a lot of you probably already know a lot of things about professional video monitors, but I had some fun discussions this morning. Actually, I heard Bob giving some great trivia that I've never talked about at the show, so this is new, right? Bob was talking about, obviously, everybody knows what this is, right? This is the inside. This is a tube, specifically a Sony tube, and obviously it's made of glass. Does anybody know why it's made like this? This isn't a trick question, I promise. Dell? You have an answer? No, I don't either. Why don't you explain it? So This is exactly, it's a vacuum sealed environment, okay? And when you have vacuum pressured glass like this, to prevent implosion, there have to be certain design characteristics to that glass. So the earlier styles of glass, that's why a lot of them, so this is a Trinitron, right? Sony specific Trinitrons, but these others are not Trinitrons, like that. Whoa, not intentional.
Creepy goss.
Oh man, yeah, it's like poltergeist there for a minute. So this tube is curved along all axes, and that is to prevent the implosion. The vacuum seal cannot. It's much harder, right, Bob? If it's a flat screen, it's much harder, or the glass has to be much thicker on a flat screen because the flat design actually makes implosion more possible, okay? And implosion is simply when a vacuum falls in on itself, okay? And that's like the most unfortunate thing that could happen to a tube. So that's one of the reasons when you pick up a Sony Trinitron that is a Vega, that has the flat screens, and you're like, why does my back hurt? It is because that tube has extra thick glass in the front, and it has to have that glass to keep that integrity of that tube. Now there's some other things about tube design that I can go over with you if you'd like. This is the neck portion, this back portion, and there's an angle. You see the angle of that funnel right there. See how it's kind of got an angle? That angle is different between CRTs because this has one of the lowest angles on a CRT, and that means it can get superior geometry along the edges and a much better picture quality. When Sony or anybody expanded the size of this tube and made it bigger, they could not keep this angle because then your tube, the bigger your tube would have been, it would have had to have been 50 feet long behind it to scale up and get the same picture quality. So a lot of people wonder why your picture quality gets worse as you go up in size of the tube. It is because of the restrictions of this vacuum tube. Now, that's kind of enough about tubes. Let's get into some fun stuff. We'll start doing some fun things on these screens. One of the other big portions, so you have the vacuum tube. It has an electron gun in the back. Particle beams are shot onto the front of the screen at, I have no idea, an extremely high rate because it looks solid to us, but in reality, this is drawing thousands of lines a second. You just can't see it because our eyes aren't as good. So what we're going to do, though, is we're going to show, so this is all determined, everything on this, where all this stuff lands is determined is based on magnetism. So let's get another screen up here. And maybe we can do some things. Now, what do you think happens when you, I know many of you guys have been here, seen this. But we can get in here and I can show you how external magnetism affects things. Anybody like to draw? Want to draw? Would you like to come up and draw on a CRT? You want to draw on a CRT? Come here. You can do it too. Take this magnet for me. All right? Go up to that screen, the red one, and just touch it against the screen. Okay? Oh, yeah. So, right? Let's try to draw something here, okay? These magnets, they're almost powerful enough. We gotta mess this thing up good. Come on, come on, get in there. So, all right, it's not drawn as good as I can, but you can see how, what we're doing, there are phosphors in these screens. There are phosphors in these screens. They're all specifically landing in a spot. And, here, you want to try? Sure. They're all specifically landing in a certain spot. So this tube has like planned on these phosphors to be in their specific spots, but going up with a magnetism has just scrambled them. They're all over the place now. They're not in their right forms. Let's, thank you guys for volunteering. I appreciate it. Thank you very much. We're going to try to see if we can get this back to normal. We'll see what it looks like now.
I don't think mine's right.
Oh, there we go. Oh, sorry. So, thank you.
So yeah, see, we've got these weird streaks, this weird stuff, and like, what are we gonna do? Like, what we've done is we've messed with basically our colors now, and we have all kinds of purity problems. And when it gets extreme like this, you can use this tool, which is called the degaussing coil wand. And this is just going to create a huge electric field. Now, hopefully this thing doesn't shock me like it tried to a second ago, because this thing is just nothing but a electrical beast here that's going to put out a big pump. Now, watch this. As you put here, you'll really see, look at that. Really magnetized. That can really mess up the colors. So this is a good example. Like, this screen's supposed to be what? I don't even remember at this point. Red? Okay, so it was originally red. We've got our reds all squished in the middle, our blues up top, our greens, and like, there's nothing that, I don't know, if we turn it off and turn it back on, it's not gonna make any difference, right? No? I mean, like, we can't do anything about that. So thankfully, again, we have the degaussing tool. Let me show you. Okay, so the secret to this, start about here, and closer, closer, closer. Further, further, further.
Wizard.
And bam, you're like instant color balance. So, if you ever got yelled at for taking a magnet and drawing on your parents' CRT when you grew up, somebody here probably did. You should have gotten your parents a degaussing wand for Christmas.
What if you don't have one? Would it be
If you don't have one, good question. So let's do
I
something
can
else.
actually answer that
Go for
too.
it.
Because one thing that you can do, if you have multiple CRTs and if you have one that you know does have a degaussing circuit in it, so when you turn it on, it makes that boom, the natural degaussing circuit in it powering up. You could do the tactic that I like to call make them kiss. So you take the two tubes, put them face up right next to each other, and then power up the tube that isn't the problem, the one that does have the degaussing coil on, and you can actually use the degaussing coil from one tube to degauss the other. And if you have two tubes that have degaussing circuits in it, there you go.
Yeah, it's a great point, and I forgot to introduce my special helper today, Steve from Steve's Assorted Stuffs here
Hi.
to help me. And I also have a plant in the audience here, Dell. Hey, Dell brought his own wand. He's got one handy, so Dell's the arcade master, and he'll come up and help with any questions too.
He's Pat Sajak on Vanna White.
So, but that's a good point. So if you come in here again, you mess it up. Let's actually do this because it's working better. Some of these monitors will have, this is not like, this TV has no degausser beyond when you power it up originally. It'll degauss quick, and then there's no way to like make it degauss again. But these professional monitors, they built in a degausser and a degauss button into them so that when people were in the studio and some new intern went past the TV with a big magnet in his pocket, they could just press the degaussing button on the side of the monitor, and these monitors have that built in so they automatically do it and refresh it on their own like that. It's just that's not as cool as using the wand. Right? So, thank you guys.
PC monitors have it too.
Oh yeah, lots of PC monitors have it, do have an external degausser. So that's a little bit about magnetism. I know there's a lot of people are concerned, obviously, rightfully so, about safety with the CRT, right? What are some myths or some things you've heard? Don't open the back of that CRT, son. It'll kill you, right? I think that was the first thing I got told every time I just poked my head in the CRT, but I'm still here, so thankfully. So there obviously is a lot of voltage going in, thousands, like 31,000 volts or something, right? Dell, does that sound about right?
Yeah.
Going.
30,000.
Yeah, 30 in here, but the amperage on it is really low. And from what I've always been told, it's the amps that get you. It's the amps that make you go down for good, and the volts don't do it. So I'm not going to show you this today, but I have heard of people actually improperly or not discharging a CRT and then hitting it with their hand. The worst story was from a time I had a phone call with Save on Pat. Does anybody know who Save on Pat is? Heard of that name? Okay, Save on Pat is like a legend in the CRT world. This man like wrote the little manuals on half the PVMs, designed them, worked for Sony for 40 years, and before that he worked for B&K testers. So I talked to him and I said, Pat, has anybody, I can't find a single news article anywhere that anybody has ever said, Johnny Dum Dum died from screwing around in the back of his TV. So I've never seen it. And he said, oh, Steve, it's not actually going to get you. So he said, one time there was a guy working with him, and he didn't discharge a big tube, and he was wearing his wedding ring. And as he was servicing the TV, he went up and got about as bad of a zap as Pat said, this was the worst one he'd ever seen. And he said the poor guy fell over. How do I say this in a family-friendly environment?
It's a good line.
Relieved his pants, yeah. So he just had to get a new pair of pants and was in a bath and was very much heckled for the rest of his career at Sony. So that's the worst I've ever heard. Now, this PVM, I'll show you this first off. I'm going to power it down and then I'm going to discharge it. Oh, this isn't the side with the stairs. So we're going to discharge that one, and then we're going to move over to the wild one, which is the little mag. And that thing might not be the same because it's not going to have the number of safety equipment. So we'll talk about discharging first, and then really what is the big danger on these things, more than that, honestly, and in a second. But first, I'll power off this one, and then I'll roll it around.
Quick question while you do that. Does
Sure.
the degaussing work from a PC monitor to a TV?
Yes.
Yeah.
Yes, you can do that same way.
field.
Right. It can be. There's even people. I've never really done it because I've got the coil, but some people say they can get magnetism enough out of a drill, which we could test. I've actually got a drill here. We can see if that works. But they claim that. So I'm going to show you like the what's like. Let's see here. Making sure it's one. No, we want to discharge this. Sony also was like trying to make everybody be brave. And they're like, hey, don't worry, you're not going to get shocked here. You don't need to just discharge it like you stick a thing under there. You need to pull the anode cap off and then discharge it. Okay? But I'm going to be honest with you guys. If you all are not comfortable like in here, and if you're not comfortable in the back of this, you don't have to take this off. You can discharge it while it's sitting like this before you remove the cap. You could literally just click to any part of this ground shell. This is literally just a actually it's a ripped off piece of a extension cable. Extension cable. Duct taped around this flathead screwdriver, and it just runs out to this point. It's just a simple conduit, conductor. And you could go under here and pop this like that, but Sony wanted you to not do that because you're going to scratch up the back of their beautiful tubes under there. So they wanted you to go ahead and pinch that and remove it, right? And they wanted you to be real tough. Remove that and then discharge it. But at the end of it, everybody can see, no zap. That's because these have a bleeder resistor in them. When you power it off and you hear it going, like kind of hear it, if you can hear it, like that's usually the bleeder resistor discharging the energy slowly out through that bleeder resistor. Now, I have no idea what the documents from Magnavox said, okay?
Slap it together.
They could have said anything about whether they wanted their guys to put it off or leave it running, but what we're going to do is we're going to turn this guy off now. And I've been running it for this simple reason. Actually, I forgot to use the microphone. I've been running for this simple reason, just to get it nice and full of energy for everybody. Nice and fulfilled. And hopefully, this will work. What's going on with that? Who's this?
Phone back.
It's Dell's phone. It's Dell lit his phone. Oh man, what a prank! My own helper left the room and left his phone. Oh,
That was that team guy.
it's your phone going off.
Oh, sorry. That's my son. I gotta go get him.
Oh, go get him. Come on. All right, we've lost Dell. All right. But look, I'm going to be honest with you. If you ever were to work on one of these things, you're probably crazy. But if you do, you should just do the method I talked about, discharging in that. And look, this is not something you really have to buy. This is a homemade tool. Like I made this when I started working on CRTs 10 years ago, and I've never changed it. This is the same thing.
You made that in a cave with a box of scraps.
Just a box of scrap cable. I soldered this to the end of the cable and then taped the other end to this. So I'm going to carefully try to get this anode cap off because I have a feeling this is not going to be discharged. But hey, look, if I do zap myself, any of you come up here, the first one to resuscitate me gets a free t-shirt. Okay?
Am I excluded?
Ooh, okay. Let's hope. Let's hope for a show now.
Would you like me to hold the microphone close?
Ooh, you can do that. Where should we park this guy? Yeah, you might short
Not on
out
me.
on the microphone. Okay, we're gonna get around the ground strap. CRTs have a strap generally on the back of them that you can connect to. It's a ground strap. It's connected to the ground loop. All right, let's see if we can get in here. And I hope it does zap, but we'll see. You ready?
Well, I got so close.
Ooh, yeah, a little zap. Did you guys see it?
Yeah.
Okay. So I just want to make sure everybody saw that. Sometimes too, you'll have residual electricity left in that anode cap. Not always. And then sometimes you can come back and get a double zap. I don't know. Oh, there's a tiny zap. So what happens there is you get see when it doesn't discharge like that, you need to do a couple discharges on it. Right?
Sometimes four.
Sometimes 4.
On your cave monitor.
Yeah, as that tube gets bigger in size, it's going to hold that energy a little longer, and it's going to hold more of it. And what happened there is we discharged the original energy, but there was still enough energy to roll around and start building up back within that vacuum to make a little bit of spark out. And that's probably one of the most feared and maybe misunderstood parts of a CRT. Before we go any further with something else, does anybody have any questions about it?
Actually, do you unplug before you discharge? I didn't actually see you.
Okay, great question. The question was, do you unplug the TV before you discharge? Yes. I always unplug. Yeah, you do. Because if you discharge that thing and you have that anode cap on and it's plugged in, and let's say you accidentally bump the power button and it comes on and you got a live anode cap floating around, it's gonna be a disaster. So always unplug it. Thank you for asking that.
Yeah, size. Say, what if it was like a 36 kV Trinitron?
Well, KV Trinitron should have a bleeder resistor.
Good. I got a fixed one. So.
Okay, yeah. So you are probably okay, but I would still act like it didn't.
Yeah.
Okay? Especially anything that size. Now, if you get into the other brands, like not Sony, a lot of them won't have. And if you go in that larger one, this zap would have been much more impressive.
My question with that, does that carry more voltage though, or?
Well, it does. That's when you're ramping up, right? This might only carry, I don't know, 20,000 volts, and where that one is probably 30,000 volts. But again, it's low amperage, and I want you guys to think about something too. Like I said in my story about Pat's poor assistant, it is a direct, small zap. You saw that. It's not like a constant current flow. So that's why it's just mostly painful.
What if it was on?
If it was on, it would be constant current. That's not, yeah, we're, again, we want it unplugged.
I've never noticed it.
Scott?
Does that resistor ever fail? You ever seen it fail?
I do not know, but that's another great question. So you asked if the resistor fails. Another great reason to just always act like it doesn't have it, okay? Just because Sony made it, again, I mean, look, to me, CRTs are some of the most unbelievable manufactured machines man has really ever invented. It's a collaborative piece of machinery that has lasted an impressive amount of time to this point, right? These machines are from the 80s and 90s. I can't think of a single, I'm sorry, modern day electronics people, I can't think of a single electronics device made today that'll be worth a hill of beans in 30 years, or will even operate. So they are hardy, but there are parts on them that can fail because of that. It's not the CRT, it's the other components that generally fail, and that's what a large part of my normal business is restoring the life to those other components and preserving the parts that are irreplaceable. Any other ones?
Do you have a recommendation for how long to hold your discharge tool there?
So after that zap happens, you don't have to really hold it there. I like to do, I don't know why this is, some weird habit, but I just like to tap it. Oh, you did a little again. Yeah. Dip it and then like rub around it like a circle. I don't know why though. I don't think it probably does anything.
I want to say you should never handle it with your hand.
Handle what?
Always discharge it underneath the cup. Like,
Oh, well, no, but that's what I told him, yeah, when your phone was going off. Yes, sir, in the back.
So I've always heard that what you really need to fear are like power supply capacitors in the chassis. Is there any truth to that?
Yes, okay, the question is like, what else should we really be scared of? Power supply capacitors and other things? Yeah, that's more likely. Not only that, the more dangerous thing about actually the most dangerous thing about a CRT is the fact that you have to work on them most of the time while they're turned on. And there are a lot of points on here that are exposed electrical lines where high voltage is running through, low voltage is running through, AC, DC, all the great bands are there. Okay? And I'm not gonna lie, I've been doing this so long, I've accidentally touched boards. Heck, I was working on Bob's CRT today and I touched a board while it was hot and it gave me a little zap. So it can, that's bad. Also, when you're working on a board, you definitely can go in and discharge the capacitors. I'm going to tell you that you need to be as fearful of the, I've never heard anybody hurt themselves on these capacitors, but they definitely zap because they also hold a charge. The ones that hold the most charge, or the ones that zap the most on these power supplies for this are not even the electrolytic capacitors. They are the, what do they call those? The chiclet capacitors? Like
ceramic ones?
Yes, ceramic capacitors. I've always seen those when I run across with I just like run a screwdriver across the boards, hitting all of them like this, and those are the ones that spark more than the electrolytics. So don't just think, oh, the electrolytics, I went all over those are fine, and then you're gonna get zapped and you think, oh man, I don't wanna ever touch a CRT again. The chiclet or the
Ceramic
capacitors are also holding energy. There's also some points on, so you'll also notice, even though these are fairly different levels of hardware, they look very similar inside, right? There's a lot of similarities between the two. So one of the things that determined that magnetic field is this right here, these copper things. They're called the deflection yoke. That creates the magnetic field that gives us our good vision or our good screen on the front. And those do have points on them that hold voltage. Thankfully, these are covered with plastic shells, but on many of them, these probes will be just like, that will be off. And this will hold voltage up here. So if
If this isn't here, and you see these live probes like this, if you want to come up and look at this, anybody, you're welcome to come up and, you know, walk and look at this if you want to. Any of these probes here will hold voltage. So if you do like that, you're going to burn your hand, okay? Because when you manipulate a yoke, which we'll do here in a minute, you have to grab the yoke and you have to move it while it's turned on most of the time, because you don't know what's happening on the screen as you do it. So, cheaper TV, not really a lot of security. Actually, this one's called a hot chassis, which means there's no like isolation transformer in it even. So you can't modify these because you could have a high voltage line short out to your like composite video mod. And then you go to plug in your composite video and you've got hot electricity coming out there and you get lit up. So these guys are pretty much are what they are. And now, before I get on anything else, does anybody have any other quick questions? All right, look at here now. Jake.
I was wondering, like, while the TV is off, you said with discharging, anything else that we need to discharge or look after not while the TV is plugged in? That can give you a nice...
I mean, like I said, except for like you don't want to go put your hands down in that board area. Thankfully, like they have some things here, but again, when you're handling like boards like this, you want to try to get them from the top or from these positions, because you're not going to be able to discharge all of that until you take it apart. But really, that's the big thing, is just the anode. That's the only thing holding the most, and then the caps. But even on here, you can see where we have another safety precaution from Sony. This has high voltage running in the back of it. There's a plate here, so you can't just bump against it. Here you can, so if you like do that, you're again lit up when it's turned on. But any other questions about this, Scott?
Is there a way to like diagnose something's hot just by looking at it? Is there
Good question.
You would know it's a hot TV?
He was asking if there's a way to know that it's a hot TV. I mean, you just have to, that's a little bit more of a high-tech thing where you have to kind of analyze the build-out of the specific board. You have to look and say, okay, I see the high voltage coming in. There's no like isolation transformers. The path's running straight into the flyback, and it runs around the rest of the board at a couple points. And so that's more of a like higher end, but a lot of these older TVs, and there's even older Sonys, and there's old great looking Sonys from the 80s. They're hot chassis, a lot of them, that are composite only, and they can't be like modified because of that. Some of them thankfully already have composite built in, but unfortunately it's not super simple, because sometimes you can see what looks like isolation transformers, and it's just smaller transformers that aren't really the main grounding of the monitor. Generally speaking, when you work on these, you want to work on them with an isolation transformer. And that's a transformer that isolates it on its own power, just so you don't blow up anything else you're working on with it. Because again, if it's live, you can ground it out. Anything else before?
Hey Steve, real quick, I'm gonna head out.
All right.
After the panel,
Yes.
meet me by the Pac-Man machine. I'm gonna use a rejuvenator.
Yes. So, guys, if you want to see something really excellent that we couldn't show off here, Dell's holding a BK467. You can, thanks. Yeah, you could. He's going to hook that up to a Pac-Man machine that's missing red, and we'll be doing a demonstration of that, like rejuvenation testing and everything. It's a very cool process.
I'll meet you guys down there.
Okay, cool. Thank you.
All right, thanks.
All right, so yeah, definitely check that out. We're running kind of low on time. Does anybody have any questions real quick? Yes?
So I'm actually going to be moving an arcade monitor. It's a Wells Turner on Monday, and obviously those don't have the backing. It's just the silver like chassis.
Yes.
Do you have any recommendations before I pick it up, or just move it in general? Should I attempt to decharge the cap?
Yes, you should discharge it. You should disconnect. You should disconnect like the lines going into the monitor, obviously, and then I would just discharge it. I wouldn't leave. I mean, you could discharge it under the anode cap just to be safe, but you don't really have to. It's just it would be safer for you, but
if you're not gonna do anything with the anode,
No.
it should be heavily on there enough that, I would just check to make sure it's still on there good, like look at it, make sure it hasn't been loosened or anything.
Got it.
But, yeah, just pull it out and be extra careful around the backing area, because that's all exposed kind of like this, and you don't want to hit the neck on anything. Any other questions?
Real quick, the tool you use to discharge the tube, does it matter where that like port goes? Like, does that?
Yes,
do
it
you
needs
not
to
grade
go,
it over, or-
I always ground, now you could just ground it to anything. I mean, you could ground into something that's a ground and, I mean, you could literally put it in the ground.
Not the ground. I just mean like the physical contact of the cord. Like, should you make sure it doesn't touch any of the components?
Oh, yeah, you don't, right, yeah.
I
You
didn't know
want
if
to.
it was like an insulated, you know.
Like this is all, the outside of this, yes, it needs to be insulated. And you can see how I've got that run all the way up here?
Yep.
I just want this end exposed of steel and this end exposed of steel. The rest of this is, you know, protected because I don't want to have, like I see a lot of people make this tool and they like to use like a super long screwdriver, right? And then they clip it down here. And then they just clip something here and then they run it. And then, so now you've got this super long wand like this, like Steve's got. And now you've got like,
Mine's long.
so, but I mean, so it's just hotter. That just means this whole area is getting that. And that just gives you more exposed metal to tap against something, okay? Scott?
When I look at the back of different TVs, I notice that some have magnetic strips on them, some don't. Does that speak to the quality of the tube, that they're being supplemented with those strips or something?
Great question. Great question. So we're talking about strips. So let's do this because we're about to run out of time. Let me fire Betty back up, make sure she's got her anode cap in, and we'll do this. So I explained a little bit about magnetism and that magnetic field being made by the deflection yoke. And even though the deflection yoke does a pretty good job, it's not perfect. So you do have to use, these is what the strips he's talking about. These are actually taken from old TVs and old monitors. And you're welcome to come look at them. They're all a variety of types. You have ones that look like this, and different ones that look like this that are just actual magnets on a piece of plastic. This is like a Sony fancier one from a PVM. And then this one is made with literally, like you can make these yourself now with a material called Moo metal, I think it's called Moo metal. And you tape it to you cut little pieces and you literally tape it to a plastic strip and you make new strips because these aren't made anymore. And what these do is these help clear up corner issues. We're going to switch over to a different screen for this. There we go. So this one has a bunch of strips in it. Let's just take all these strips out because Betty doesn't really need them. So there's like 3 strips in the back of this. Let's see what happens when I remove all 3 of them. Not much. Okay. So like what we should be able to see is if you want to take a look, you may have to come closer, but if you want to come look at this corner, you'll see kind of what these strips do. Now, almost got a little zap there, but don't tell anybody.
Free t-shirt.
You see, does it? It wasn't that good enough. Somebody zap him again. Zap him. So if we look up, I mean, it's very difficult to see, but if you see up in the top corner, there's color separation. So sometimes you will come in and the monitor will look like that. And that's like you've done everything you can with the yoke, and you'll still have a nasty corner like this. And that's the case where you would try to add a strip to like correct it, hopefully, maybe, but we've introduced that negatively. So the strips are generally added in there to compensate for just a little bit of screen issues. Now the yoke, here, I'll move the yoke around as like the last demo here.
This often goes wrong on a lot of Trinitrons when they The yolk sag, you always hear
Yolk
on
sag,
forums.
right? So the yolk has to be seated properly against the back of the tube. And if it's not, stuff happens. So this is moved back, the yolk is moved back from the tube about 1/8 of an inch. How bad does it look? Terrible? Terrible. See, so terrible. And literally that's just like a little bit back. That's it. So that has to be properly set. Steve's talking about sag. If this thing, let's say over time, like there's wedges in here, and this starts to turn to one side, does the other side look funky? Like the right side, does that look funky? Or one of the sides? Yeah, and like that. So this is like what happens when people are like, I don't think my yoke's exactly tilted right. That does happen on larger tubes all the time. And so you have to come back here. Yeah, the glue dries out on these little wedges. This is what it's setting against. These wedges are glued to the back of the tube. So honestly, there's great guides on how to do this. But basically, if you have to get that up against there in the right spot. And then, like, you can add, if one of these falls out, you can just reattach it kind of to where it was and try to push it up back to it.
So they're not necessary, they just kind of hold it then.
Well, they are kind of necessary because they actually give you that proper distance. Because if you remove them and you go too close, you have problems like we just saw when I was further away. So like if you get rid of them, you won't have great geometry. It won't look as bad as it being further back, but it'll look wonky around against the corners. So that's literally why it has this little, there's a little gap, like about this big usually, about, I mean, not a couple millimeters or centimeters, between the tube backing and the yoke. It's never touching it all the way.
Can you show us how you're grabbing the yoke to do those?
Yeah, so I mean, I'm literally just like grabbing it.
We do it on mag.
If you wanna,
Got it.
right, that would be nice. I don't have that much equipment yet. All right. No, go for it. So, I mean, you see these copper lines, like they look dangerous, right? They look pretty nasty, but they are coated in an enamel, okay? Because they're not just wound up wires just sitting there. They're coated in an enamel. If that enamel ever does become compromised, it'll make the screen look crazy. Like, because it's basically shorted out and there's a burn or a misstep, and it doesn't, I've never seen it, there's voltage running through it, but it's meant to be touched and manipulated because it has to be like this. So I'm literally touching it just along here, but again, this has a protective thing here. If a lot of them look like this, so then you have to it's getting worse. You have to stay away from that, right? I mean, if you're working on this one, you can't get near these nodes. This one actually has them on the bottom of the yoke, and coated and covered, and then it's got some adjustments up here, but that's all set at the factory, okay? All right, guys, I really appreciate it. Is there any other questions? I've got to have 5 minutes for questions.
Show where those strips go in?
Yeah, they go in just, I mean, with the corner strips, whatever corner you're working on, stick the strip in that the corner that you're trying to manipulate. And it's not like perfect. You have to play around like this and move around, find the sweet spot. Then you set it. You stick them to the tube. You can use simple, it doesn't matter what your adhesive is so much, like a two-sided tape is great. I like to use this stuff called Viz-Torque because it just sounds cool. No. You go to the automotive department or the automotive store and you can get this kind of stuff because it's mostly used in automotive things. This is like a lighter, almost marker glue, and it's quick drying. So you put it there, and if you have to remove it, it comes off easy, and it's not super thick like something like RTV silicone. Like you could also use this. You could really use any of this stuff to adhere it. Once you get it in there, you want to make sure it doesn't move. So it's a great idea to cover it. Any other questions?
Yeah, have you seen or worked on that 43-inch
CRT that came from Japan.
Well, I mean, this is just like,
Yeah,
I know
that's
a lot
screen
of
with Shane.
I know, I think a lot of you guys would probably, I mean, the question was about Shank's PVM. It's a 43 inch. It's a great documentary if you haven't seen about how he acquired it. It's one of the best. Right, it's the best probably CRT video ever made.
Hey.
Hey, there's always next, right? Next year's CRT Oscar.
I'll find the second one that's out.
But I mean, it's just such a great story. I have not gotten to see it yet, but I have. I mean, Shank and I are pretty close, so I have an open invite to go anytime and do that. So that's on like it's like the travel to Mecca, the travel to the giant black cube, right? This is the giant black cube of the.
It's the monolith.
Of the yes, it is Stanley Kubrick's monolith. Okay.
So you had dropped a nugget at one point, I think it was on Twitter, about some Sony PVMs being able to take both the left and right audio into the in and out on the back.
Yes.
I cannot find anything else on these, like which ones they support. Can you tell me a little bit more about that?
So the funny thing about, and I don't know why this is, the funny thing about these monitors is the ones that support audio, a lot of them will have in audio and out audio. And I don't know why it is, but with Sony, you can, I don't, and I've never found this documented, but you can just stick your left and right audio in to the out and the in, and it will wire it together through your single speaker. And I'm not sure, maybe Bob remembers, I think we talked to like Steve about this.
Totally safe.
It's totally safe.
That anybody that says it's dangerous, it's a complete myth. Steve debunked it. We even talked about it in a video we did somewhere on the website.
Yeah, that's why I was like, I remember, I thought it was you guys, which I was like, if Steve says something, it's good enough for me, because I'll never be on Planet Steve, okay? He's on his own planet. This is the guy from HD Retrovision who made the HD Retrovision cables with me. But any other questions, anybody?
Do you have any recommendations for SCART switchers?
SCART switchers, yes, G-SCART. Number one. Still or no?
Still number one. The Games Care one is great too, and then Artemis is mixed switch. So you can sell
Okay, yes, I forgot about that one. That one's new.
And if you want a passive one, the Retro Gaming Cables one is under $100, and it's just a standard push button, 6 in, 1 out, but it's perfect. Nothing wrong with it.
Yeah.
Where anything from Holiday Express, but even the blue ones, you can buy 5 of them, and it's totally good. One completely different, the same length, same cell.
Yeah, and I would highly recommend, if you guys are looking for any kind of like information on scalers, please go check out retrorgb.com and like look in there for like a lot of the documented work. I mean, thousands of hours of studies on those kind of devices have been done, and Bob's put awesome work into that, so definitely go check that out.
So I have both a 32-inch Sony and FD300 and also a 36-inch FD310. And the FD310 is like very noticeably better picture quality to the point where I really wanted to SCART mod the 300. And I'm wondering, would you ever mod a 310? Do you think it's worth it to do SCART on that?
Man, 310s, I've had like bad luck with 310s. Like I've never had one that's like working and up in my shop, and they've always been solely like bad shorts in them that the one unfixable from last year on my record is an FB310. So I don't really know. There is, if you're on Twitter, I would highly recommend getting in touch, or this guy's name is Six Tanks, and he knows more about the modification design. His name's Matt Ross. He's on like the CRT. He does a lot with Andy King. He's out in Hawaii. But from what I can tell, every time I try to think about something, like I used to think it was pointless years ago to RGB mod something with component. Because I was like, why really do it? But actually I was completely wrong. There's a lot of TVs that do a bunch of color processing and filtering over the component video input, and you get to bypass all that crap and just go raw straight in with your RGB video, and you're getting raw video. So, I don't know, if it's capable to do it now, I like to do it, just to see and have the flexibility of the TV. So my viewpoints have changed over the years, where I was like, don't really want to do RGB mods, so now I do a lot of them. All right, guys, that's like our time here. Again, if you guys want to come back and have any conversations, I'll be down in the booth for the next couple hours. And please check out Dell's. We'll go down there and we'll work on a CRT rejuvenation, which is not something that's done very often. It's very cool. Thanks again.
All right, everybody, thanks again for watching that presentation. I hope you enjoyed it and learned something. I always love being with a lot of CRT friends and having great questions. This audience was incredible, had a lot of awesome questions, and was really interactive, so it was a lot of fun. If you need any kind of CRT repair work done, or, you know, want to just have an expert like me talk to you about CRTs for some reason, the best way to do that is through Patreon. That's how anybody can get access to my workshop, is through Patreon. And that's the only way to get access through my workshop, is through my Patreon. I don't do it any other way, and I never will. So anyway, if you're interested and want to get more involved in CRTs, there's a link in the description for this video on the Patreon. And again, the Patreon membership has a $10 tier that you must be on, and that's how you get in, so that the workshop, or not, sorry, the workshop, I'm sorry, that's how you get actual work done to your CRT, is that repair level tier listed right in the Patreon. But there are also other tiers if you just want to have an open dialogue with me. You know, it gets as low as $1 a month, okay? So that's just specifically for if you want to be in the repair queue. All right. Thank you again for watching the presentation today. I have a awesome video to accompany this that's actually on the Retro World Expo itself and my booth at that expo. And so that will be coming. There's also some other great CRT videos that are going to be made by other creators in the CRT space, one being Steve, the helper from this. So I'll put a link in the description too for Steve's Assorted Stuff, his channel, so you can check it out, because I'm sure he's going to have a lot of stuff about the CRT wall he made at Retro World and some other things. So please make sure you subscribe to that channel. I'll see you guys next time with some more retro content.